So today we're going to go over the surface area of cones. That's supposed to say cones, not pyramids. I forgot to change it, sorry. Cones. On the very top, it's supposed to say cones. No, this one right here.
Oh.
Okay, so we're finding... We are finding the surface area of cones. I really need you guys to focus here. There's too much talking going on. So, a cone has a base in the shape of a circle. Okay, so yesterday we looked at pyramids. Pyramids had one base. It was in the shape of a regular polygon. Okay, now your cone, the base shape is going to be a circle. The axis of the cone is the segment with endpoints at the vertex. And the center of the circle. Okay, so in your pictures here, your axis goes from the vertex, which is the very top, okay, and it goes to the center of your circle or your base. Okay, so this one, if I were to draw in the axis, we would go from the top, okay, to the center point. So that axis would be slanted there. Now, if that axis is also the altitude, okay, or the height, okay, altitude is also the height, then the cone is a right cone. If not, then the cone is an oblique cone. Okay, so a right cone, you'll see this height from your vertex to the center, and it is perpendicular to that base. Okay, so your altitude and your axis are the same. In an oblique cone, your altitude or height it will be different from your axis, which goes to that center point there. Okay, so we do have different parts of our cone. Your base is going to be that circle. Just like yesterday in our pyramids, we do have a slant height. Okay, so in this cone at the right here, your slant height goes along this edge of your cone. Okay, so that is your slant height, and again, we label that as that cursive L. Okay, so that is your slant height. All right, so surface area of a cone, same formula as yesterday. It's 1/2 P times L plus B. Okay, so our surface area is 1/2 P times L plus B. Where again, that 1/2 P times L is again your lateral area. Okay, so lateral area is always that first part in that surface area equation. So, do you remember what P is? What's P? It's the perimeter. Okay, it's of the base. Okay, and that capital B value is what? The area of the base. Yeah. Okay, so we have the perimeter of the base and the area of the base, and again, that L value is your slant height. Now, to find the perimeter of the base, since our base is always going to be a circle, perimeter of a circle is the circumference. Okay, so to find that perimeter, we're going to use 2 pi r. Okay, so to find that perimeter, we use 2 pi r. And since our base again is a circle, for this capital B value, to find the area of that base, we're going to use pi r squared. Okay, so for perimeter we use 2 pi r. For area we use pi r squared. Okay, questions before I go through our first couple examples? All right, so first thing we want to do in letters A and B, we want to find either the height or the slant height like we did yesterday to start off with. Okay, so letter A, we have this cone here. This length from the vertex to that center point is your height. Okay, so that means we want to find the slant height along that lateral edge there. Okay, so we want to find L. So again, our height and then that base create a right triangle. So how do I solve for L? Pythagorean theorem. Okay, so I would have 2 squared plus 2 squared is equal to L squared. Okay, 2 squared is 4 and 4. So we have 8 is equal to our slant height squared. We need to take the square root of both sides. So our slant height, or L, should be about 2.8. And that would be in whatever units. They didn't give us units for these ones. Okay, questions on A. So for some of these cones, you may have to solve for the slant height before you can find the surface area. All right, then letter B. This time we are given the slant height. Okay, so again, that slant height is that lateral edge right there along your cone. However, this time we're not given the height. Okay, so we want to solve for the height this time. And again, it creates this right triangle, so we can use the Pythagorean theorem. So I'd have 6 squared plus h squared, h, equals 10 squared. Okay, since 10 is your hypotenuse. So we end up with 36 plus h squared equals 100. Subtract 36 from both sides of your equation. H squared is equal to 64. Take the square root, and you do end up getting h is equal to 8. Okay. Questions on that first section there? All right, then our next section, numbers 3 and 4, we're actually going to find the surface area of the cone. Okay, so for surface area, again, we need P, we need L, and we need B. So I need to find all 3 of those values. So starting with P, okay, P is the perimeter of the base. Okay, up above, I said to find P, we need to use 2 pi r. Okay, so to find our P value here, we'll use 2 pi r. What's r in this picture? 9. So I'll plug in 9 for r. Okay, so I have 9 times 2 times pi. I got about 56.55 centimeters. Okay. Next, I want to find the slant height. Okay, I'm not given the slant height in my picture here. Okay, slant height is this edge right here along your cone. So how do I solve for that slant height? Pythagorean theorem, good. So since the slant height is the hypotenuse, that's your C value in the Pythagorean theorem. So we have 9 squared plus 12 squared is is equal to L squared. That's 81 plus 144 equals L squared. So we have 225 is equal to L squared, and take the square root, both sides. So you get L is 15. Is that what you got? Yep. Awesome. Okay, so now we have the slant height, or L, is 15 centimeters. Okay, next I want to find B. That's the area of the base. So again, I wrote how to find the area of the base up here. We use pi r squared. Okay, so we're going to use pi r squared. Again, r is 9, so we plug in 9 for r. So we have pi times 9 squared. That's 254.47. And that's in centimeters squared. So now that I have P, L, and B, I can find my surface area by plugging it into the formula above. Okay, so my surface area will be equal to P, which is 56.55, times L is 15. That's divided by 2 or multiplied by 1/2, same thing. Then add on our capital B value of 254.47. Now when you enter this into your calculator, you need to be careful. You cannot multiply 56.55 times 15, add on 254.47, and then divide by 2. You have to only divide that first part by 2. Okay, so yes. Okay, so this should equal 678 I rounded to 6 centimeters squared. Okay, so make sure you can enter that correctly into your calculator and get that same answer. Okay, questions on our first example. All right. No. Next one. So for this one, again, we're finding the surface area of this cone. When looking at this picture, I know I have to find P, which is the perimeter of the base. However, you're not given a radius for this circle. Okay, we need to find what that radius is. So again, since we create this right triangle, you can use the Pythagorean theorem to solve for that radius. So this time, since I'm already given the hypotenuse, and that's your C value, we would have r squared plus 12 squared is equal to 13 squared. We have r squared plus 144 is equal to 169. Subtract 144 from both sides of your equation to get r squared is equal to 25. And then take the square root of both sides. So our radius is equal to 5 centimeters. Okay? So now that I have the radius, I can find the perimeter. Okay, and again, for perimeter, I need to use the circumference formula, so we are using 2 pi r. So we have 2 pi times the radius we just found is 5. To get 31.42 centimeters. Okay, next I need L, or the slant height. Okay, what's the slant height? 13. Okay, and then capital B, we have to use, we have to find the area of the base. To find the area of that circle, we use pi r squared. So we have pi times our radius is 5, and that is squared. And I got 78.54 centimeters squared. So now that I've found P, L, and B, I can find the surface area using our formula we highlighted above. Okay, so the surface area is equal to, our P value is 31.42 times L is 13. That quantity is divided by 2. Then add on our capital B value of 78.54. And I got 282.77. And that's in centimeters squared. Any questions on number 3 or 4, finding that surface area?